So, guys, I want to be sure you have been practicing all of the things we have been doing so far. If you're yet to, please practice them. We're going to solve all the past questions quickly on all of these things, and that's why I'm trying to upload the videos in a short manner so that I can take your time to study them, and consequently, you'll be able to do very, very well. So, we're moving on to the part five now. So, the part five, we want to quickly talk about the test for oxidizing and reducing agents. One of the things you need to know is that JAMB asks questions on this often, and they will ask you that even WAEC, any form of exams, so they can ask you that what will happen to a what you observe here is just a color change. I told you something when I was teaching you redox. I said when reduction happens, oxidation also happens simultaneously. So when one species undergoes oxidation, the other species undergoes reduction in our previous classes. So now, if I want to test for a reducing agent, I just need to add an oxidizing agent. So the reducing agent, you remember your reducing agent is one that will undergo oxidation. That means for you to undergo oxidation, the oxidizing agent must have worked on it. Let me do a quick revision of that. So let's do test for reducing agent. So we want to do test for reducing agents and oxidizing agents. So we want to test for reducing and oxidizing agents. Let me show you something quickly, or like a reminder. Look at this: H2S plus Cl2 to give me HCl plus S. So in this equation, which one is the reducing agent? That's the first question. I've not started, but I want to remind you of what we've done before. So which one is the reducing agent? So if you look at this one will be plus 1. If you remember, sulfur here will be minus 2, chlorine here will be 0, hydrogen here will be plus 1, chlorine here will be minus 1, and sulfur here will be 0. So that means chlorine has gone from 0 to minus 1. Going from 0 to minus 1 is reduction. That's reducing. Going from minus 2 to 0, that's oxidation. That means that the oxidation number has increased. So for this one is undergoing what we call oxidation, while this one is undergoing reduction. You remember what we have been doing. Now, which one is my reducing agent here now? So that means that the one undergoing oxidation is called the reducing agent because it is the one that made this one to undergo reduction. The electron lost by this one is gained by this one. Do you understand that? So the one undergoing oxidation loses electron. That electron is gained by the one undergoing reduction. You remember that definition. So now that you understand that, that means this one undergoing reduction is the oxidizing agent. Because without this one cannot undergo oxidation. That's why we call this one oxidizing agent. It is the agent that brings about oxidation of another species. So this one allows this one to undergo oxidation. This one allows this one to undergo reduction. That's why this one is called reducing agent, because it makes this one to undergo reduction. Do you understand that term? So now that is cleared, now let's say I want to test for a reducing agent. Like this reducing agent now, I don't know what it is, but there's something I know about this guy. So I will add this guy. I don't know, maybe it's a reducing agent or not. If reducing agent is not present, or if the oxidizing agent is not present, then this one will not undergo oxidation, right? So if I want to test that, oh, is this guy an oxidizing agent? Like, I don't know. Let's imagine I don't know what is here. I now added it to this guy. Then you are going to see a color change. If that color changes, then that means that what you have added is an oxidizing agent. If it is not an oxidizing agent, you will not see a color change. So let me take you for an example. So let's look for oxidizing agent. So now the first one you would do that they can ask you in exam is that if you will use H2S and you add an oxidizing agent to H2S, you don't know what it is, but you are expecting to see a color change. So what you are going to notice is that H2S is colorless. So normally H2S will undergo oxidation, Abi. So what will make it undergo oxidation? Because of the presence of the oxidizing agent. So now what will it change to? This colorless will, it give us sulfur here. If you look at this, so it will change this guy to sulfur, and that sulfur is yellow solid. So if you see a yellow deposit of solid, then solid yellow deposit, then that means that what you have added is an oxidizing agent. But if it is not an oxidizing agent, when you add it to this, there will be no color change. So they can ask you, an agent that changes the colorless A2S to yellow sulfur is what? That's an oxidizing agent. Do you understand that? So this oxidizing agent oxidizes this one to sulfur. So that's what we have there. You can write it in ionic form. The reason is that this one is plus 1s plus 1s, so nothing is happening to the hydrogen. You remember where we started from. So that means that this one went from S2 minus, and S2 minus is colorless, to what now? To S. And that S is 0. It has no charge. Then this one is yellow in color. So when you see that yellow color, then you say that what you have added is called an oxidizing agent. Let's check another example. So my other pen is not right. So number 2. So look at this number 2 now. Let's take Fe2 plus. Fe2 plus normally is dirty green. Is dirty green. But now I want to change it from Fe2 plus to Fe3 plus. That means that if I'm changing it to Fe3 plus, what has happened? Oxidation number has increased. So if oxidation number should increase, then that means this guy has undergone oxidation. Then you expect me to see a color change. Fe2 plus is dirty green, but Fe3 plus is reddish brown. So for this guy to have changed from plus 2 to plus 3, something must have taking electron away from it. Loss of electron is oxidation. So that means that for it to undergo oxidation, there must have been an oxidizing agent. So oxidizing agent will make it to change color from dirty green to reddish brown. So they can ask you that. So oxidizing agent will oxidize Fe2 plus to Fe3 plus. So you are testing for an oxidizing agent. But if the color did not change, that means what you have added is not an oxidizing agent. It's as simple as that. So let's look for another example. There's this example about starch iodide complex and all of those things. So the problem here is that if I have let me test for reducing agents first. So now that we have tested for oxidizing agents, let's test for reducing agents. So now for reducing agents, number 1, the common question is KMnO4. Now KMnO4 is potassium permanganate and the color is purple. When is this color purple? When this guy is, if you calculate the oxidation state of this guy, we have done it before, it's going to be +7. When it is in the +7 oxidation state, it is purple. But when you now add a reducing agent to it, reducing agent will reduce it from +7 to +2. So you're going to have Mn2 plus. And this Mn2 plus is colorless. So if you add reducing agent to KMnO4, it's going to reduce it from +7 to +2. But if what you are adding is not a reducing agent, then you won't see the color change. So that means if you see this color change from purple to colorless, that means what you have added is called what? A reducing agent. Number 2, you have K2Cr2O7. K2Cr2O7, the color is usually orange. So this chromium here, if you calculate the oxidation state, is going to give you +6. But if you add a reducing agent, a reducing agent will reduce it from +6 to +3, Cr3 plus. And this Cr3 plus is green. I usually remember this with OG. So they can ask you that the color will change from what to what. It will change from orange to green. So this one is PC, like PC computer. So PCOG or PCOG, however you can remember it. So when you add reducing agent to KMnO4, it will change it from purple to colorless. When you add reducing agent to orange to K2Cr2O7, it will reduce it to green. So we are going to see questions on this when we start solving past questions. Get used to that. Now, I need you to note something quickly. Some species are said to act as both reducing agent and an oxidizing agent. I have some things to explain here, but due to time. Now, look at something. Look at something quickly, just to quickly explain something. Now, let's say I have H2S. The oxidation state of sulfur here is -2. Do you believe? You can do the calculation. Let's say I have SO2. The oxidation state of sulfur here is +4. I don't know if you believe that. In H2SO4, you can calculate it. The oxidation state of sulfur is +6. So sulfur can have different oxidation states depending on the compounds. Now I want to quickly tell you something. Do you know I can go from +4 to -2? If I go from +4 to -2, is that reduction or oxidation? Going from +4 to -2, that's reduction. Very good. So reduction. So the one undergoing reduction, that means this guy can go from here to here. It will undergo reduction. In that case, now it will be called an oxidizing agent. You know, I told you that the one that undergoes reduction is an oxidizing agent. So it can also go from +4 to +6. So going from +4 to +6, is that oxidation? Yes, that's an increase in oxidation number. So that's oxidation. So that means that the one undergoing oxidation is known as what? The reducing agent. So you can see a question that which of the following can act as both oxidizing agent and reducing agent? That is SO2. So SO2 can act as both oxidizing agent and reducing agent. There are some other compounds like that, but let's get used to this ones first. This is the common one they give you in UTME. SO2 can act as both what? Reducing agent as oxidizing agent, because it can change its oxidation state to the highest form. If it is at the highest form, then it can only reduce. But if it is at the lowest form, it can only increase. But now it's at the intermediate form, so it can either increase or reduce. So which means it can act as both reducing agent and it can also act as an oxidizing agent. Please watch this video again for you to get clarity of what I've said so far. So it's time for us to start solving questions now in the next video.